In this video, I want to discuss a concept that we've probably touched on briefly, but haven't really gone into in any great depth, and it's a concept that you may be tested on later this week, so it's something you ought to know really well, and it's called geometric means. Which is sometimes considered to be synonymous with the mean proportional. Okay, and the way we define a geometric mean is in terms of a proportion, which you could probably get from this word here. So that if we have two values, let's call them A and B, and we want to find the geometric mean of A and B, of A and B. Okay, we want to find the geometric mean of A and B. We need to solve the following proportion. A is to the mean, the geometric mean, as the geometric mean is to B. Okay, so it is the M that we are looking for. And we need to solve for M. That's actually not so hard to do. So let's go ahead, and if we're given A and B, and we want to find the geometric mean of two numbers A and B, let's now solve for M. We can cross multiply, which means we get AB equals M squared. Okay, and if we take the square root of both sides, like so, we get M equals to the square root of AB. Okay, so that is how you find the geometric mean of two numbers. So let's say that, for example, let's look at a specific example. Let's say example 1. We want to answer what is the geometric mean of 11 and 15. Okay, so basically what we do is we're going to use this formula right up here, and we can apply it directly. The geometric mean is equal to the square root of the two numbers multiplied together, 11 times 15, which is equal to, I'll just take my calculator out here for one, 11 times 15 is 165, and that is my answer. Okay, simple as that. The answer is the square root of 165. I cannot put it in any simpler terms because there is no perfect square that divides into it. Let's look at another example. Example number 2 would ask, what is the geometric mean of 16 and let's say 50. Okay, so again, the geometric mean is going to be equal to the square root of 16 times 50. It's really that simple. You take the two numbers, multiply them together, take the square root, and that's what gives you the geometric mean. However, in this case, it will take a little bit of work to get the square root into the lowest, into the simplest form. So let's go ahead and actually I'm not going to multiply this out because I just have to factor it again. So if you remember the trick that we used in class, the square root of 16 times 50 could be represented as the square root of 16 times the square root of 50. And I'm doing that because I already know 16 is a perfect square. So why bother multiplying it out and then having to factor it from scratch? So this way I know that I've got the square root of 16 times the square root of 50, which is 4 times the square root of 50. But am I done yet? Not quite, because there's a perfect square also in the square root of 50. So I can set this equal to 4 times, and I think you'll know that the square root of 25 times the square root of 2 is going to give us the square root of 50. You can multiply under the radical sign, and 25 is a perfect square, which is 5 squared. So this gives us 4 times 5 times the square root of 2, which is the same thing as 20 times the square root of 2. So this is the answer. This is the geometric mean of 16 and 50. Now you can have another type of a problem where you could ask, you could be given the geometric mean. Okay, so let's say given that the geometric mean is 6, or the geometric mean of two numbers is 6, one number is equal to 3, find the other number. Okay, so in this case, you could be given the geometric mean, and you could be given one of the numbers, and now it's up to you to find the other number. So that's just a matter of remembering that the formula is that the mean equals the square root of a times b, where a and b are both the numbers. We know one of the numbers is 3. We know the mean, the geometric mean, we could put a little g there to remind us it's the geometric mean, is 6. So for geometric mean, we substitute in 6. We have the square root of, and let's let this a equal to 3. And b is the other number that we don't know. So we will leave b as a variable. So we'll take the formula that the mean is equal to the square root of the product of the two numbers, substitute in the mean that we know, substitute in the number that we know, and now we need to solve for the b that we don't know. So then, how do we solve an equation like this? Well, the first thing to do is to square both sides, because you really always want to try to get rid of the radical sign. So let's go ahead and square both sides. That gives us 6 squared equals the square root of 3b squared. And I hope you remember from class that when you square a square root, you remove the square root sign. So the radicand, which is the number underneath, is all that remains. That really actually simplifies things. So we have 3 times b, this is the letter b, equals 36. Well, at this point, all we have to do is divide both sides by 3, and we get b equals 12. Okay, so our answer is the other number is 12. And we can check that. So let's check that the geometric mean of 3 and 12 is actually 6. So let's go ahead and use our formula. The geometric mean equals the square root of the two numbers multiplied together. This time we're taking 3 and 12 as the two numbers. And the question is that going to equal to 6? Does 6 equal the square root of 12 times 3 is 36? Yes, it checks. So therefore, we've solved this problem that given a geometric mean and given one of the numbers, we can find the other number. Please study all these 3 examples because you do need to know this for the test coming up later in the week.